In our last example, our graph is going to get a little bit complicated because we're going to use a step-by-step approach to graph this function. This function's base function, I'll call it, is just the graph of f of x equals x squared. Now let's see what we have to do. If we have this graphed, and maybe I'll go ahead and graph that. 0, 1, 1. Negative 1, 1. 2 squared is 4. Negative 2 also. And then if we went to 3, 1, 2, 3, 4, 5, 6, 7, 8, 9. 3 squared is 9. So the graph of f of x equals x squared looks something like this. Not too smooth, but you get the idea. Okay, from this graph, how does this compare to it? Well, I can tell you the easy part that I remember the most is when you take a function and you put a -4 at the end of it, that just means shift it down 4. Shift whatever this is down 4. When you replace x squared with x minus 2 squared, that means shift right 2. And then multiplying that by 3 means vertically stretch by 3. Okay, so let's go through this kind of step by step, which more steps than you would probably use to graph this. Basically, it's not going to have the same shape as this graph. Not exactly the same shape. It's going to be a taller version of it because this 3. It's going to be 3 times as tall as this one. It's going to be shifted left, right, and shifted down 4. So let's go one at a time. This I've already done. Now, shift f, this function we just did, to the right 2 units, giving us what would be this. I'm going to call it h. So if we shift that to the right 2 units, well, that just means, let's see, should look, if I could draw well, it would look exactly the same, only 2 units to the right. All right, so this would be what we called h in our little recipe here. Let me label this one as f. Okay, so now we've got this done. Notice all we need to do is multiply it by 3 to stretch it, and then shift it down 4. So, okay, so what does this, how does this graph, k, stretching it by 3 is what we're doing. How does this graph compare to this one? Well, there's only a 3 in front of it. That's the only difference. So that means the value of y is going to be 3 times the original value. So if you plug in a 2, you'd get k of 2 equals 0 because you have 2 minus 2. So we know it starts right here at the same little point down here as the graph of h. Now it needs to be 3 times steeper. So instead of having a height of 1 here, it's got to have a height of 3. 2, 3. 1, 2, 3. And I'm going to try to draw the whole graph from there. I don't know where it's going to cross these other graphs, but you get the idea that it's just stretched to be 3 times as tall as this graph of h. So this would be the graph we're calling k of x. Right there. And lastly, we will do one more thing. Now from this, we have this graph already. Now the only thing difference between this and the graph of g is this minus, oops, let me lower that a little bit. The only difference between the graph of k and the graph of our g, which is rewritten down here, is the minus 4 there at the end. That just means drop the graph of k, which is 3 times x minus 2 squared, down 4. So I'm going to drag this graph here down 4 units. 1, 2, 3, 4. So it would go there, there, and then it's going to look something like this. That's not perfect. I only plotted about 3 points and kind of estimated it. It should be just like this one, only drop down. I should have made it maybe a little bit thinner, but you get the idea of that. So just kind of as a review, all we had to do, since we know what this graph looks like, we replaced the x, x is being squared. We replaced x with x minus 2. That means shift to the right 2. We multiplied by 3, which means stretch it, make it 3 times as tall. And then minus 4 means just drop it down 4 units.